Hi, this is TJ from smokescreendesign.com. I'm bringing you another video, just something I wanted to discuss. This video from Regents University of California, and this is part of their science course. And well, as this says here, the Earth is round. Derp, not sure what derp is, but the Earth is round, and this video is being used as proof to prove that the Earth is round. But there's a problem with it, and I'm going to show you. Let me draw a box around this. So if you notice, the water is within this box. The water is below this line, the water is above this line. And this FOSS is coursework, maybe for homeschooled, maybe it's for classroom, I'm not sure. And I don't know what the purpose of this video is for. It's part of a science course. Is it part of trying to prove that the Earth is round and this ship is going over the curvature of the Earth? I'm not sure exactly. So that's what people are saying that this proves, but let's take a look at it. So we see just a little bit of water below here, but it's basically within the box. Now if you see the ship, now the ship is starting to get inside of the box. So we see the ship appears to be dropping kind of significantly, and this video is being cut, but now look at the water. The water is above the line. Now the water is above the line again. Now the water is even going up. So is this water magically rising? And we see the ship is going across. Now let me just, alright, let's just keep this going, we'll come back. And the water, look how high this water is now. Now it's hard to tell exactly, and this water just dropped, and still see part of the ship there going over. It's hard to tell exactly what's going on here. Are they cutting parts of the video out? Are they moving the camera down? I mean, what's happening here? What exactly is it that they're doing? So this this ship, when it goes over, and we have to go from the side because I can't draw the curvature going the other direction. But when this ship is, on the same level as us, this is what the ship looks like, and this is what it should look like. But if that's the curvature of the Earth and it's starting to go over the curvature of the Earth, the mass of the ship is still going to be perpendicular with the ship, but if we're still over here, it's actually going to be leaning forward. It's not going to be straight up. And do we even see that? Do we see that this ship's mass leans forward? Well, no, we don't. So if you have a building that's over here on the curvature of the Earth, buildings should be leaning like this. Now let's watch this ship and see, do we see this mast? Do we see it lean forward if it's going over the curvature? Until we see that they basically cut and keep cutting this video to make this drop. But it also appears that either this camera is zooming out, and that's why we start seeing more of the water in this direction, which makes it look higher, or the camera could be getting lower to the ground, which then would make the water, I don't know how to say, but the water appear to be going deeper or to be going further out. So now this ship appears to be going over the curvature of the Earth sideways. It's not going straight over, it's going over sideways, which is kind of odd. Why would the ship be going sideways? And it only appears to be going sideways because either they're zooming out or they're lowering the camera, so it's actually pushing the ship out further that direction. And remember, it's going sideways. See, it's still going sideways, sideways. Now it appears to be going straight on. So it was sideways, and then it appears that it just turned to face straight that direction, and since it did that, it actually looks like it dropped even further. But we see this mast is still pretty straight up. And we see the ship is, we can still see it. I mean, it should be leaning over. It shouldn't just be straight up like that. Still appears straight up. So I don't know how far out this ship is, depending on the how far out. I created a spreadsheet, and I'm going to pull it up here with some formulas that you can determine the curvature of the Earth, and I made a video on this so that way you can download this until I make it on my website, to where you can just type in the numbers on the website. So anyway, let's say if that is 3 miles out, then it's going to be 6 feet of curve, so it'll drop down 6 feet. But they're trying to say that whole ship went down, and let's say if that whole ship went over the curvature of the Earth, that would have to be at least like 50 feet, I'd say. So let's say that's 5 miles, so that's 16 feet, 6 miles. So if that was 6 miles out, then there would be 24 feet of curve. I don't know how tall that ship is with the mast, so let's say 7. So 7 miles out, then there would be 33 feet of curve. And this is just using the Pythagoras theorem, that you have a right triangle and you've got a squared equals b squared plus c squared. And so this is the point of where the camera is, and then this is where the ship is going out, and then here we use the radius of the Earth, which is round, and I figured it's 3,960. So the ship going out here, if we draw a line to that, then we subtract the radius, which takes us up to the curve. Subtract the radius from this line here, and that would give us the feet of curve, or inches, or miles. So if that was 7 miles out, then that would be 33 feet of curve. So it could be 7 miles out or 8 miles out. That would be 43 feet of curvature. So that's just the drop down here, which that thing did not look like it was going over curve. It clearly looked like it was just someone edited that video to look like that, or zoomed out, or did something like that. So just fakery. Thank you to this university, for Regents University of California, for providing us some fakery, if that's what they're doing, trying to teach kids that this proves the curvature of the Earth. So let me see this one here. This video. Now what tends to happen is people say, well, I stand there and I watch a ship and I watch it go below the curvature of the Earth, because the base of the ship goes first and then the rest of it goes. But really what happens is that just because of our depth of view, it appears to be that way, because we can only see so far out, and especially there's the you have the fog or the moisture or whatever in the air, and there's just other things that happen to where we can't see clear. As you see, this is kind of foggy over here, and it just appears to go below the Earth's curvature. But when you zoom in, if you use something to zoom in really far, you will see that you can actually see the whole thing. It really did not go below the Earth's curve. Now, if you use a like a camera or telescope and you zoom in as far as you can and you keep watching it until it looks like it's going below the Earth's curve and you can't zoom in anymore, then you will need something else to zoom in even further than the capabilities of that to really verify if it did go below the Earth's curve, or if you just reached your horizon. Based on your visibility and the height you are off of the ground determines how far out that you can see. So I've had people say that they've zoomed in really far with a telescope and watched it go over the Earth's curve, but like I said, at some point your visibility of an object is going to change when it's moving. Alright, so that's it for talking about the Earth's curve, and there's not absolute proof of physical proof. Might have it in numbers, but when you take a look at it with your own eyes, with your own science, with your own experimentation, you'll see that it doesn't exist. Even if people tell you it does, do your own science, your own experimentation to find out.